Welcome back to 11.1. So now we're talking about the relationship between the units of length, area, volume, and capacity. So for any unit, there are corresponding area and volume units. So if we have a unit of length, then the area would be a square unit and the volume would be a cubic unit. So a square unit is the area of a square that is 1 unit by 1 unit. Because you can, if it's 1 unit by 1 unit, and we're going to have much better drawings in a moment, 1 unit by 1 unit, the area covers it 1 by 1. So that is a square unit. And if we have a cubic unit, that is the volume. That is 1 unit by 1 unit by 1 unit. And it's all that whole filling there. It creates a cubic unit because we filled it with a cube. So let's take a look at some better pictures. So again, we have our unit of length, just 1 inch. But when we find the area, how much it covers, it's a square inch. And when we find out how much it fills, it's a cubic inch. And the same goes if it's a centimeter. And this is a really wonderful website, this usecubes.com, for you to build out and kind of see cube drawings. So when we write the units of area and volume, we use an exponent of a 2 for area, and we read it as a square unit. So this would be square inches, and this is square centimeters. And you can think about when we square things, right? That's what that means. 2 squared, 3 squared, 4 squared, square inches. And then the exponent of 3 is, cubic inches and cubic centimeters. And this is just a good note here. We don't really write unit squared. We say square unit. We don't really write unit cubed. We write cubic unit. So if it doesn't actually have like an inch, a meter, we would use unit. And so this can get a little bit confusing, but it's best to read 2 inches cubed as 2 cubic inches rather than cubed, because when we read it as 2 inches cubed, it makes it sound like it's a 2 inch by 2 inch by 2 inch cube, which has a volume of 8, not 2. And so we're going to look at an example that kind of illustrates that a little more. So which of the following describes the same volume? So we're going to draw these out, so bear with me. So for a 2 inch by 2 inch by 2 inch cube, so that is 2 inches by 2 inches by 2 inches. So the volume of that would be, if I were to multiply all threes, that's going to be 8 inches cubed. B is 2 cubic inches. 2 cubic inches. C is 2 cubic inches. And D is 2 inches by 2 inches by 2 inches. So that is 8, because we're going to multiply 8 inches cubed. So what are the same? A and D and B and C. And you can see how, my goodness, that can get really confusing really fast. And here it is all written out for you. And again, I encourage you to build these into the drawings, into that website. So what does it mean to say that a shape has an area of 8 square inches? Okay, well, that means it had the 8 1 inch by 1 inch squares cover the interior of the shape. Right? This means 8 square inches. That means I take 8 1 inch by 1 inch squares, and when I take those 8 1 inch by 1 inch squares, I can cover the entire interior of the shape. All right, and here it is written out for you. Why is it not completely correct to describe volume as length times width times height? Well, that is only true, if you recall from previous knowledge, that is actually only true when we're talking about a rectangular prism. That's not the volume of a cylinder or anything with round, right? That's length times width times height. But what about a cylinder? Right? That's not length times width times height. That would be, I would be filling it with these circles. So it's not completely correct because this is only talking about a rectangular prism. So what is a better way to describe what volume means? Okay, and also just to add here, this is also a formula. It's not describing volume, it's giving a formula. A better way to describe volume is it's the measure of three-dimensional space, or what fills the shape. So give some examples. So okay, it could be 300 cubic inches, right? And then that would be 300 1-inch by 1-inch cubes filling that shape. And there it is written out if you want to see it again. All right, so now I've got these cubes, and these did come from that website. Oh, actually, these came from PowerPoint, but I think I do have a picture with that website. So use cubic inch blocks or cubic centimeter blocks to make a variety of solid shapes that have a volume of 24 cubic inches. So literally any shape I build. So 1, 2, 3, 4, 5, 6, 7, 8. So if I want 24, I think I only have 7 here. So if I want 24, then it's literally any shape I can build with 24 cubes. So here are 24 cubes. So it is literally any shape I can build with these cubes. And I'm not going to actually build anything because that's going to take a long time. But literally all that it means to have a volume of 24 cubic units or cubic inches is that I can make it with 24 cubes. I can make a pyramid, I can make a rectangular box, like I can make a rectangular prism. There's all sorts of things I could do here, and it's any shape. So you go ahead and give these a try. Press play when you're ready to see the solution. And let's move on to volume versus capacity. So what is the difference between volume and capacity? Capacity is essentially the same, but it can be used for the volume of a container, the volume of the liquid, or the volume of the space taken up by a substance. So amounts of liquid are usually measured in units of capacity rather than volume. So deciding which unit to use can be tricky. So generally there is more than one unit that could be used. So in the metric system, we could use millimeters, centimeters, meters, kilometers to measure lengths or different distances. But if a classroom is 10 meters long, then yeah, if it's 10 meters, it's also 1,000 centimeters and 10,000 millimeters. But we're not going to say, 10,000 millimeters. That just doesn't make sense. We would say 10 meters long. You know, so yes, you can use lots of different units, but there are some like best units to use. So for each of the following items, we're going to state the U.S. customary units and the metric units that might be the common that would be appropriate. And so the volume of water in a bathtub. So I'm not going to say ounces. Think about a 12-ounce soda, right? I'm not going to say ounces. I might say gallons. Think about a gallon of milk, right? Because if I'm talking about gallons, that's a bigger unit than ounces. And then maybe I'll say liters if we think about kind of a gallon of milk and a 2-liter soda. Those are pretty similar kinds of sizes. So now the length of a swimming pool. So I'm not going to say gallons of water because we're talking about the length, not volume. So I might use feet or yards. I'm not going to use inches, right? Because pools are not typically decided in inches. I'm not going to use miles. Those are too long. But, and then I'm going to say meters. I'm not going to say kilometers because those are more similar to miles. So the weight of a slice of bread. So now that's not very much. I might use ounces. Those are our kind of small units of weight. And then I'll use grams. So you're going to go ahead and complete this problem with a little bit more difficulty. Press play when you're ready to see the solution. And that concludes section 11.1.